All aboard bus number 2. My name is Talia Plaskett and I'm the Protected Crop Specialist at Perennia. Today we're going to be touring technology in agriculture. We're going to be visiting a handful of our specialists and we're going to be looking at things like weather stations, the use of apps for crop management and data collection, as well as the use of drones. So grab your coffee, get set, and we're going to hit the road. Our first stop of the day is with Michelle Cortens.
Thanks for joining me. So at this stop, I'm going to talk about a tool that we've been working on at Perennia, and it's for the smartphone. So, we've got this tool in our back pocket. Let's see what we can do with it. So we've been working on an app that mainly the focus is to help with chemical thinning decisions. That's kind of where we're starting with the app, but we're building this base that can be extended to several different crops in the industry. So let's take a look at how it's used for apples, and to do that we're going to have a flashback to earlier in the season at the timing when it's used. Alright, so this tree is set up for too much crop. We do have chemical thinners to manage the crop load, but their efficacy depends on fruit size and so many other factors at the time of application. So research over time has developed some models that can help us determine how much of that crop is set or how much will drop. And of course, those models need data. So oftentimes to gather that information, it takes one person counting and one person recording on a sheet. So we can definitely streamline this process. The same goes for any other crop where data is being recorded on a sheet of paper. So this app is called Orchard Tools, and what does it let us do is the question. So shown here, the user can record the diameter of king fruitlets to determine if they're in the size range for chemical thinning. So it's a very short window of time when this can happen. So they can record the diameter of each fruitlet in the cluster. And so here I'm numbering those fruitlets from 1 to 5 with a permanent marker. So by measuring the same fruitlets over time, these measurements can be used to track the fruit growth rate to determine if fruit are growing and will then stay on the tree, or if they're slowing down, which is a predictor that they're going to fall off the tree. And here's another cluster. So after measuring the marked clusters on the tree, we can click the button to move on to the next representative tree. And that's what's nice about this app and this tool. It's built for agriculture and it's built for the crop that it's being used for. It can look like those fruits are going to set, so after one chemical thinner, there isn't much time to adjust the crop load again. So doing this process can give us a little bit more prediction and some more information for making decisions. And the goal is to target 1 or 2 fruit per cluster. So here we are again where we tracked the fruit growth rate, and the thinning treatments actually brought us down to 2 fruit here. Some other user-friendly features include the data being automatically saved to the device each time you hear that chime. You can also have multiple collection dates. It performs these functions locally on the phone, so there's no Wi-Fi or mobile connection needed. There's functions for reviewing averages and graphs to get immediate feedback while in the field, but also the option to export that data to be used in other models. And we field tested the app in 2019 and 2020, leading to more improvements that we could add to the app. This year, the app was featured in the international magazine, The Good Fruit Grower. You can find it on the Apple App Store for iPhones, iPods, and iPads. So the app is one way to collect more data to help with management decisions. And I think that's something we're working towards in agriculture. I know it takes the luxury of time to record all of that information, but if we have the tools that help us be a little more efficient, then maybe we can start to try these practices and see if they work for your farm. Thank you. Have a good tour.
Thanks, Michelle. That was a great first start to the tour. Next up, we're going to be looking at the importance of weather stations across a handful of commodities. Francisco Diez is going to get us started.
Hi, I am Francisco Diez, Viticulture Specialist at Harrington. Today, I want to discuss with you about weather stations and their impact in vineyard management decisions. To do that, I will take you to two different locations. First, in Avonport, where I am already located, and after to Sheffield Mills. Both places they have a distance of 20 kilometers in red line. Even though these places are quite close, each one has a different microclimate which can impact differently to the vines. To discuss more precisely this topic, we will choose one variety, a red Vitis vinifera, well known in our province, Pinot Noir, which has been quite well adapted to our local conditions. In both places, we'll see that each weather station will provide the precise data to take the best decisions in each place. Weather stations can be installed in different places in the vineyard, or outside from the rows, or at the beginning or in the middle of the row. In this condition, we have a weather station installed at the beginning of the row, following all the indications by the manufacturer. The weather station has a couple of main pieces, which I will mention. First of all is the anemometer. This measures the wind speed. Above there, we can measure the direction of the wind. At the top is to measure the amount of precipitation fall. Below is to measure temperature and humidity. More sensors can be included in the weather stations depending on what you want to measure. For example, it's possible to measure soil moisture, sun radiation, or include other sensors like a leaf wetness. This is to predict disease impacts. Let's talk about the main phenological stages in this Pinot Noir in Avonport. First, bud burst. Approximately was on May 23. The next phenological stage, bloom, was approximately on July 5. As today, July 14, these clusters they are in fruit set. Here we can see a cluster 10 days after bloom with a full pollination. We are in an organic vineyard, so having a weather station, it's very important to measure the main parameters such as humidity and precipitation. In that way, we can evaluate when is the optimal time for our next application. Now we are in Sheffield Mills. 20 kilometers in rect line from Avonport. Here we have the same variety, Pinot Noir. Similar to Avonport, I will give you the main phenological stages reached here in Sheffield Mills until now. Budburst started approximately on May 20. After that, bloom started on June 28. If you remember, in Avonport we had bloom approximately on July 5, which is a week later than Sheffield Mills. In practical, it means that here in Sheffield Mills we should be spraying or doing some canopy management decisions earlier than Avonport. Compared to Avonport, in Sheffield Mills, bloom started earlier, which means that fruit set was earlier, and that's why it's possible to see now a larger development of berries. Just to conclude, today we have been in Avonport and Sheffield Mills, observing the same variety, Pinot Noir. Even though these two locations are not so far, the plants behave differently. Which characterize these places that they have their own weather stations, providing temperature, rainfall, wind speed, and humidity. All these informations allow to each vineyard to take their own decisions in terms of spraying applications, canopy management, and weed management. Thank you for watching Weather Stations in Vineyards.
Up next is going to be Michelle Cortens.
Welcome, thanks for joining me. At this stop, I want to talk about how some new weather data and some weather stations this year have been used to help with management decisions. So the first obvious one being for the tree fruit growers, that it helped with a disease called fire blight, where we use a model to predict when there are infection periods. And that model and that disease are highly dependent on temperature and rainfall. So there are 10 weather stations that were placed in different microclimates throughout the valley this year, and the data from those weather stations did show us that we've got those obvious microclimates, but more importantly that they do impact the infection risk for this disease. So it was used to help with some management decisions. And in some cases, we did have the opportunity to spray after an infection event happened, where the forecast was incorrect, and we ended up seeing some higher temperatures and higher disease risk. Also for that disease, one of the risks is when plant tissue gets damaged. So when post-tropical storm Elsa came through, we were able to look at the information from these weather stations to see where the highest winds were being recorded and where we should start looking for tissue damage to see if there was a trauma event that could create a risk for this disease. So that was fantastic to have that weather information. So speaking of the wind, just on a usual day where sprays are going on in the orchard, the wind information I hear has been really helpful to check and see if wind conditions are too high for spraying or if the spraying can continue. Also really handy to have that information when the manager is off farm giving instructions to the farm crew. So that's been great. Also, the temperatures, so evaluating chemical thinning programs, we've been able to look back at the different temperature information in the different regions to see if it might have played a role in how much of the fruit dropped or didn't from the different thinning programs, to be able to fine-tune those programs for the future. Also, in terms of temperature, freezing temperatures were a risk earlier in the season. So some folks who were kind of closer to the valley floor were able to monitor those temperature conditions to see if they were approaching some critical temperature values. So really handy to see if they need to be concerned, start looking for freezing injury. Luckily that didn't happen this year, but it was a good tool to have just in case. So thank you, it was good to see you, and hope you have a good tour.
Now on to Hugh.
Hello everyone, my name is Hugh, wild blueberry specialist at Perennia. Growing crops will always be depending on the weather where it is grown. Data collected from weather stations are important information to help farmers to determine management schedules and needs, such as planting, pesticide applications, irrigation, etc. The growing degree days model are used to estimate the growth and development of plants and insects during the growing season. The weather data attempted from on-farm weather stations in wild blueberry fields can be used in a wild blueberry phenology model, which will predict blueberry plant emergency and tip dieback in sprout fields, and fruit bud stages, bloom time, and fruit mature in crop fields. Those critical blueberry development stages are related to spring herbicide application, fertilizer application, soil and leaf sampling, fungicide application, pollination, and harvesting schedule. With accurate on-farm weather data, growers will be better to plan their management schedules. Other than the blueberry phenology model, weather data can be used in other pest models to predict pest development and plan the best timing for pesticide applications. Another important use of the weather data attempted from on-farm weather station is to help with wild blueberries disease management. A lot of serious blueberry diseases are associated with blueberry plant development stages and weather, especially heat and wet periods. Take Morellinia blight for instance. It has the highest infection risk when blueberry fruit buds scales start to separating, and warm and wet periods is expected within a few days. Blueberry growers can use weather station data to determine fungicide application needs and spraying schedules.
Alright, let's head out and check out some protected structures as well. Alright, so far in the tour we've looked a lot at the benefits of having a localized weather system in a field setting. And I just wanted to talk a little bit about having weather monitoring equipment in an indoor space. So by growing indoors, obviously you're offered some, if not total, protection from the outdoor elements. Now while this is a great added bonus to this type of system, you do have to realize that now climate management and balancing is in the hands of the producer. So by maintaining set temperatures, humidities, CO2 levels, air circulation, all of these parameters now have to be balanced, managed, and monitored. And the only way to do that is through the use of weather monitoring equipment. So this station, for example, has a set temperature from a high and a low point. Now in this tunnel we have automatic roll-up siding. So what that means is when we hit that upper temperature limit, the motor is fired up and it's going to roll the sides up of the tunnel. We're going to see the movement of cooler air into the space, flushing out that warm, humid air that's been sitting in here, and now the plants are much happier in their designated temperature range. Alternatively, once that temperature drops too low, the motor is then triggered again, rolls down the sides, and then we see sort of the capturing of that warm air again around the crop. So by maintaining this balanced, targeted environment, we're able to much better project how the plant's going to grow and how quickly it is, when we'll be picking, when we'll be throwing it out, and when we can plant our next round of plants, depending on the crop that we're talking about. So this creates almost a very scheduled and organized growth production system, which is quite handy when it comes to dealing with retailers or farm markets. So indoor growing and climate management go hand in hand in terms of optimizing the system. That was a lot of great information. Thank you everyone for highlighting the importance of weather stations across the board. Next up, we're going to be checking in with Thomas and Hugh.
Hello everyone, my name is Hugh. I'm the wild blueberry specialist at Perennia.
Hello, my name is Thomas Harrington, and I'm the Agri-Environmental Specialist with Perennia. Today, we are going to be talking about technology usage for wild blueberry production.
Wild blueberries are a unique crop with particular production challenges. Like other agricultural sectors, the wild blueberry industry can benefit by adopting the best and advanced technology in wild blueberry production and management. While blueberry fields are often all sizes and shapes with rough terrain, which can make efficient field management difficult. This section will explore the use of new technology in wild blueberry production and how it can make operations like spraying and harvesting more efficient to reduce input use and crop damage. Today, I have my colleague Thomas with me to help me operating a drone over a blueberry field. Drone technology are already being used in other agriculture production systems, and this technology has become an essential part of the large-scale precision farming operation. Drones are used in field mapping and monitoring field conditions. Let's see what Thomas can bring to us.
So we have with us here today a DJI Phantom 4 drone. And what we're going to do is we're going to fly an automatic flight path over this field using an app on our phone to control the drone. And what the drone is going to do is take a series of photos over the field, and we're going to take those photos back to the office, and we'll stitch those together to make a composite photo. This photo is known as an orthophoto, and what we're really interested in using this here today is to look at the distribution of weeds within the field, but we can also calculate things like field sizes, so we can look at the size of the different pieces of the field, and we can also look at the distribution of bare spots as well as calculate an elevation map.
Here is a quick demo of how we set up and fly a drone to access the field where we stand. From the image and videos captured by the drone, we can see a summary of the field. The drone images and videos give a good overview of the field size, field shape, field conditions such as weed presence, bare spots, blueberry clones. From the images, it is extremely helpful to get an idea of weed species and the size of the weed patches in the field. Next, I want to show you a particular problem we found in this test field. From the video, we can see a lot of unnecessary tractor trucks presented in the field. Those trucks come from tractors where growers drive the machine for field activities, such as spraying, fertilizing, and others. Driving within the field is necessary to perform any management activities in blueberry fields. Some downsides of tractor trucks are reducing yield potential and increased diseases infection, as plants in those areas tend to be weaker and more susceptible to diseases. Therefore, reduce unnecessary drives and plan better driving routes can benefit field productivity. To improve this situation and increase field productivity, Thomas is going to introduce the GPS guidance system.
So what is a GPS guidance system? The most basic type of guidance system will consist of a GPS receiver mounted on the roof of your tractor and a display screen that is mounted inside the cab, like we see here on this machine. These systems will provide a visual guide on the screen to show where to drive and also give a coverage map to show what areas have already been sprayed. This type of system is known as a manual guidance system because the operator still needs to manually steer the tractor to the location indicated on the display. A more advanced type of GPS system integrates with the tractor and is known as an automatic steering or auto steer system. A retrofitted steering wheel with a motor can be installed, or the electronics can integrate directly into the hydraulic steering of the tractor. The choice will depend on the type of machine and GPS system used. With an auto steer setup, the operator will engage the system and the tractor will automatically steer to where it needs to be for minimal overlap. GPS systems use guidance lines to show where the tractor needs to drive for each pass. These are also called A-B lines, as the operator will usually set an A and B point at each end of the field to determine the line's location. These lines can be saved in the display so an operator can reuse them for each subsequent spray pass. So how can GPS systems be beneficial in blueberry farming? A GPS system will most importantly make your field operations like spraying and fertilizer applications more efficient compared to using basic systems like a foam marker. Less overlap on passes means there is less pesticide or fertilizer used on each application, and less field time will also mean less fuel usage. For example, if you had a 45-foot boom and you were overlapping by 2 feet when driving manually, with a GPS guidance system you could theoretically reduce this to an almost zero overlap saving you about 5% in chemical and fertilizer costs on each application. Additional benefits include less operator fatigue and the ability to focus your attention on the sprayer and booms. Since coverage maps are also saved, it is possible to resume an application at a later time in the event of a breakdown or rain. GPS systems will save guidance lines so that an operator can reuse them for subsequent spray passes in the field. This can help reduce tire tracks in the field, which will reduce yield and can potentially foster disease. Auto steering systems can very accurately follow a previous set of tracks in the field, although this is more difficult with a manual GPS guidance system. So how should you spray a field with the GPS system? The most efficient way to spray a field is usually to do 1 or 2 trips around the outside of the field first. Try to make 1 trip around the perimeter if possible to reduce adding an additional set of tracks, but smaller boom sprayers may require 2 trips around in order to give enough room to make a turn. This may especially be true if the field is odd or wedge-shaped. The goal is to be able to turn your tractor onto its own tracks when filling in the field. After spraying the perimeter, pick your straightest and longest edge and set your AB guidance line on the display. This will give you a visual guide to follow when filling in the field. When exiting a field to refill the sprayer, follow the tracks you previously made to reduce excess tracking and crop damage. The best advice is to make a plan for your tracks before starting to spray. This might involve using something like Google Earth to sketch out your plans and see where the straightest edge is first. If manually spraying, it is advisable to use straight tracks only, as they will be much easier for you to follow. If using auto steer, it can sometimes be more efficient to use a curved spray track, especially if there's no straight sides in the field. So some producers have asked, can GPS auto steering systems be used for mowing or harvesting? The challenge of using these systems for harvesting has been that some of the systems available will not operate at the slow speeds needed for harvesting blueberries. The other challenge is that relatively high accuracy is needed to minimize any misses in the field and ensure every berry is harvested. There has recently been some testing done locally at Dalhousie University to see if GPS auto steering systems can be used for harvesting blueberries, and the results have shown that the system can actually outperform a skilled operator. It has been shown that the systems perform quite well even on slopes and rough terrain. If mowing with a gang mower, GPS systems can be used as long as fields are not too severely sloped. Gang mowers will tend to slide down a slope, and a basic GPS system will not compensate for this, as it has no way of knowing how far the implement has drifted. Some more advanced systems would involve installing a second receiver on the mower in order to provide the necessary corrections for side slope implement drifting. So how much does a GPS guidance system cost? Manual guidance systems are much cheaper than an auto steering system, but they can only be as accurate as a driver. A good manual guidance system can usually be obtained for under $5,000, although there are many options available. An auto steering setup will be very dependent on the configuration of the machine. Some new tractors are already set up to do auto steering and may only need a GPS receiver or display added for this functionality. So how accurate are these systems? With most systems, the base level accuracy of the receiver will usually be accurate to about a meter or less. There are options to upgrade to higher accuracies, but the basic accuracy is usually good enough for spraying.
In agricultural production, there are many challenges and uncertainties, but adopting the best fit and advanced technology are beneficial for your farm management.
We hope you've enjoyed today's session and have learned something about drone and GPS technologies and how they can be beneficial for wild blueberry production. Thanks for joining us here today.
Thank you.
So thank you to everybody who joined our tour today on technology in agriculture, and I hope that you can see that basic innovations can be implemented in just about any crop. I hope you consider joining us next week in bus number 1 for our tour in optimizing production. See you then!